gigawatt hour. Production is considering yearly how much they can produce the energy. That gigawatt hour in USA only Europe 150 and in Asia especially in China 1.3 terawatt hour. And which is expected by 2023 almost 5 times. If we say 5 terawatt hour means out of this almost so in worldwide we can see China having dominance over this battery production. So where we are today in terms of iron battery. So in case of the safety is still issue. In case of the energy density is moderate. Means we are expecting like 1000 kilometers with single charge, but now it's around 5 to 600 to the single charge. Because if we see in case of the battery, cost is also very important. For example, if you are going to buy Nexon car of 16 lakh, out of this 50% cost like 8 lakh cost of the only battery. The energy power density will be the same. It's moderate. We have to improve more. Life is also again important. So life will be because some of the companies they are claiming life of 5 years. Some of the companies they are claiming life of 8 years. It depends on the cathode material because LCO, lithium cobalt oxide, it's old material that having only cycle life. Cycle means what? Cycle life means what? Once charge and discharge means one cycle. 1000 cycle life means that battery you can charge 1000 cycles. After that it will dead. And an industrial point of view, if the battery coming to the its SOH, that is state of health, 80% of the original is dead. So operating temperature will inverted from -2 up to the temperature is like -22 around 50 degree. But same time we have to consider the safety in terms of the electrolyte because electrolyte is not that much stable at the high temperature. So these are the some advantages: high energy density, operating temperature, low self discharge. So what we mean by low self discharge? Self discharge is concept observed in the old batteries like lead acid, nickel amide. Means if I charge battery and just kept aside without using it, and after 1 month if I see I can count it's 20-30% discharge without load hours. That is self discharge, which happened in earlier battery, that is lead acid battery or nickel amide. But in lithium-ion batteries, there is no self discharge, longer life and less weight as compared to the earlier battery. So what are the disadvantages? It's expensive, then sealing problem, risk of explosion, leakage of chemical electrolyte, then side reaction with the charged electrolyte. Okay, so these are the variety of applications from small scale, from laptop, smartphone. In future, it's possible to go up to the flight applications. So these are the different geometry, I can say. Geometry of the lithium-ion battery, we know very well, we are aware about that cylindrical, which is also main usually using in the electric vehicle, but with the different size. So different sizes means width and height. So if I say 18650, 1850, ये साइज क्या हुआ? इस सेल का नाम है. तो 18 mm is the width and 65 is the height. So Tesla, what is it they are doing nowadays? They to reduce the cost, they are making cell larger. So what they did initially, 1865 was the main. Okay, 1865 was the main. Then they did 2140 and now 4880. So which one recently they are using in Tesla car? 4880. Means earlier was 18. Instead of they made with 48 and instead of 65 they made height 60. So 80, 65, 80. So what happened? When one cell was giving capacity of around 2.2 ampere hour, then that nowadays that forgets 80 giving capacity of 3 times more. Okay, it's like 6 ampere hour. So what will happen? Production cost as well as size, everything will decrease. Then another is prismatic, which we are using in our different like laptop or cell phones, and then coin cell in our wristwatch or another application, and thin arrow flat battery, some voice applications or which headphones which you are using, that's small kind of thin flat batteries. So before going in detail, we will understand the basic mechanism. So you can see one side is the cathode, one side is the anode. Cathode is some layered oxide like LCO, and one side is the graphite. So what will happen during charge? Lithium from cathode will be the source of lithium, and anode will be the graphite. Graphite is nothing but the source of carbon. So what will happen? That lithium will go inside the graphite during the charge. There will be formation of Li6, okay, and that lithium will Li6 means 6 carbon is for the one lithium, and during discharge what will happen? That lithium will come back. That will be a simple mechanism. That lithium will come back to its original place. So these are the different materials, but the thing is that now maybe you will ask question. People are trying different these materials, cathode material, but why are not looking for another option for the graphite? Because it's the when lithium get inserted into the layer structure, there will be volume expansion take place. Simple example, consider if I am having balloon, if I put air into it, what will happen? It will expand, and when I will take it air out, it will regain its, it will not regain its original dimension, but there will be some change in the shape and size. So same thing happen in case of the anode. So when lithium get inserted into two layers, there will be some volume expansion. When lithium go back, it is expected it should show the elastic nature, means it should come to the original position, but it's not happening. So in case of the graphite, this volume expansion concept is only 10%. So there are alternative anodes, there are a lot of alternative anodes like silicon. In case of the graphite, its theoretical capacity is only 370 milliampere hour. But in case of the silicon, it's 4000. How much? 4000. It's more than 10 times. But still, why people are not using the silicon? The thing is that the volume expansion. Okay? Because in this case, volume expansion is 10%, but in case of the silicon, volume expansion is 400%. So what will happen means, when, for example, consider a single particle in single particle, if consider this is single particle of the silicon, if lithium get